Last but not least in this section, they talk about these additional corollaries to everything we've been talking about. And it says, if the derivative equals 0. Now that was one of the conditions for a critical point. And if the derivative is 0 at every point on the interval, so the slope is always 0, think of a function whose slope is always 0, then there is a constant for which f of x equals c for all values in the interval. The third corollary says, if a function, if f prime and g prime are exactly the same at every point in an interval, then there is a constant, f of x equals g of x plus c, for all in x in that interval. Okay, if you took the derivative of this side, you would get f prime, and if you took the derivative of this side, it would be g prime, because the derivative of a constant is 0. They're weird definitions, and you're like, what does that have to do with anything? So example 6, this is just introducing you to undoing derivatives, and it doesn't come until much later in some of our later chapters, but right now they're just kind of introducing the topic to you. So it says, find the function f of x whose derivative is sine of x and whose graph passes through the point 0, 2. So we want to know the derivative of what function is sine of x. And so you have to kind of make your brain go backwards. You know it's going to be some version of cosine of x, but you know the derivative of cosine of x is negative sine. So in order to get a positive sine of x, we have to make this negative cosine of x. So negative cosine of x gives us sine of x. But according to this corollary up here, I could have negative cosine of x plus any number and still get this as the derivative. So we don't know if there's actually a vertical shift in this one or not. So the way we have to write it is we have to say that f of x is negative cosine of x plus some constant c. Now, they gave us this ordered pair, 0, 2, that has a really special name, and we're going to do a lot with it in future chapters. But this little point here is called an initial condition. And the reason they give us that point is to help us solve for plus c. So 0, 2 is your x and your y value. So I'm going to plug in 0 for x, and I'm going to plug in 2 for y, and that's going to help me solve for c. So we get 2 equals negative cosine of 0 plus c. Well, cosine of 0 is 1, so I've got negative 1. So I'm going to go ahead and add 1 to both sides, and I get that c equals 3. So my function is negative cosine of x plus 3. So this graph goes through the point 0, 2, and if I take the derivative of this function, I get sine of x. So we've satisfied all of the conditions that were given to us.